In this lecture, I will talk about the Monte Carlo simulation model and the option adjusted spread in the context of valuing mortgage-backed securities. The first point to understand is that with mortgage-backed securities, cash flows depend on interest rates and the path taken by interest rates. Earlier, we've talked about regular callable and puttable bonds, where we used a method of backward induction or the binomial model to come up with the value. In the case of callable and puttable bonds, the cash flow depends on interest rates but not on the path taken by interest rates. Now, with mortgage-backed securities, it is important to recognize this fact that the cash flows also depend on the path taken. And let's just understand this point. Let's say that when the original mortgages were issued, the rate was 10%. Subsequently, the rate went down to 7%. At this point, we have a lower interest rate. There will be lots of refinancing. So there will be prepayments on the mortgage-backed securities. So there will be substantial cash flows. After that, if interest rates go back up to 10% and then down again to 7%, at this 7% point, there will be very little refinancing. So the prepayments here will be low. As opposed to the first instance where we went down to 7%. Here the prepayments will be high. From this picture, you can recognize that the binomial model, which relies on backward induction, will not work, because working backwards, if we come to 7%, we don't know whether the prepayments here will be high or not. What happens here depends on what has already happened earlier. So clearly another model is needed. That other model is called the Monte Carlo simulation model. Now, this is rather complicated, but fortunately for us, we only need to know the basic points. The first basic point is that the Monte Carlo simulation model allows you to predict future interest rates. So think of this as an elaborate computer program. Now, you are the analyst using this program. What sort of information do you give this program? You need to give this program the current yield curve, for example. From the yield curve, the program can figure out the spot rate curve as well as the forward rate curve and so on. You also feed in a volatility assumption. Based on what you know of the market, you tell the program whether the interest rate volatility is 10%, 5%, 12%. So you feed a volatility assumption. Then what this program does is generates several possible paths that interest rates might take. If the current interest rate is 8%, say, then this program, given the inputs, and these are just two representative inputs, there might be other inputs which are outside the scope of this reading. But the point is you give the computer some input and then it will generate some paths. So it might say that interest rates might follow this particular path. Let's say this is path 1. It might say that there is another possible path that interest rates will stay flat. Here is another possible path. So there will be lots of different paths that this computer will come up with. These are called the different interest rate paths. Now, why is it important to estimate these future interest rates or the different possible future interest rates? This will help us estimate future prepayments. For every path, then there will be a corresponding prepayment rate assumption. And the prepayment rate assumption is going to drive the cash flows. Now, something that I'll just say here, and then we'll see in more detail later, is that these simulated rates are the treasury rates or the market rates. If you are evaluating a security with credit risk, for example, and other sorts of risks, then is it okay to use the government rates, the treasury rates, or do you need a spread above those rates? You need a spread. So the simulated rates then need to be adjusted. You add a certain spread, and once you add that spread, then you need to add such a spread that the value of the instrument that you calculate should be equal to the actual market value of the instrument. The way this is stated in the curriculum, simulated interest rates must be adjusted to produce arbitrage-free values. If you are a little confused over here, that's okay. Just follow me for the next few slides and then this statement will make more sense. The present value of a particular interest rate path is the theoretical value of a security if that path was actually realized. So take this path P3 for example. Now based on this interest rate path, as we said earlier, there will be prepayments, so you are taking certain cash flows, then you are discounting those cash flows at the rate plus the spread, and then based on the cash flow and the rate you can come up with a present value. That present value represents the theoretical value of the security if this particular path is followed. Now, will the theoretical value be the same for every path? The answer is no. For every path, we will have a particular theoretical value of the security. So let's look at an example. For simplicity, let's say that we only have 5 interest rate paths. Obviously, for a real model, it will be more, but in an exam context, you will be given a small number of paths. So 5 paths are used in the Monte Carlo simulation to value a particular tranche, call it tranche X, and this happens to be part of a CMO deal. Based on a spread of 60 basis points, the present value of interest rate paths is as follows. In the exam, it is unlikely that you are actually made to come up with the present value. You'll be given. So you'll be given the fact that for path 1, the present value is this, for path 2, the present value is this, and so on. If I also tell you that the probability of these paths is 0.2, 0.2, 0.2, 0.2, and 0.2, so the same probability, then what is the theoretical value of the security? So as long as the paths are all equal probability, and if the question is also telling you that the spread of 60 basis points is appropriate, that is what is required by the market, then the theoretical value is simply the average of these 5 numbers. And I have picked simple numbers. So the average is 80. That is the theoretical value of our security. Before I go to the next slide, I'll just make a couple of basic points. Here we assume that the probability of every path is the same, but that might not necessarily be the case. If the probabilities are different, for example, path 1 has a probability of 0.1 or 0.4, this has 0.1 and so on. Obviously, the probabilities need to add up to 1. If you have different probabilities, then you just take a probability weighted average. That's one basic point. Another basic point is that here you are given this spread. So this is a spread. These numbers, the present value for path, these are actually dollar numbers. And the market value, given the way we structure the Monte Carlo model, the market value then needs to be 80. When we have that situation, then we say we have an arbitrage-free situation. Now, going into a little more detail and connecting this information with what we studied in an earlier reading. So I want you to do this question before listening to the answer. So which one is the packed tranche? The correct answer is Y. If you look at the range for X and Y, for X the range is 20. The possible values range from 70 to 90, whereas for Y the range is only about 5, the lowest number being 87 and the highest being 92. With a support tranche, the prepayments and the corresponding cash flows are likely to have a much higher range. If prepayments are fast, then the support tranche will be paid off very fast. If prepayments are slow, then the support tranche will be paid off much faster. So you actually expect a much higher range for the support tranche and a lower range for the packed tranche. Therefore, Y is more likely to be the packed tranche. Next point, the option adjusted spread. We've already talked about this, but let us look at another explanation of the OAS. OAS is the spread that when added to all spot rates on all interest rate paths will make the average present value of the paths equal to the observed market price, the full price in this context. Remember, in this reading, whenever we say price, we are talking about the full price. So some important points here. When we say interest rates, we are referring to the market rates or the treasury rates. And the OAS is that equal spread such that the average value of the paths is equal to the market price. In our example earlier, we had the OAS of 60 basis points. In other words, the OAS is the adjustment which helps produce an arbitrage-free value. When your model is giving a value that is equal to the market price, then you say you have an arbitrage-free value. If this doesn't happen, then there are potential arbitrage opportunities. So just hammering on this OAS a little more, there are different interpretations. One interpretation of OAS was that you start with the Z spread and subtract out the impact of the option. Here is another interpretation. Now, I'm sure you are wondering, what sort of question can I get on this? So let's look at an example. You are evaluating tranche B of a particular CMO deal and have been given this data. So you are given the different paths, and with these different paths, you are also told that if the spread is 51 basis points, so for path 1, you are given this. So if it's 51 basis points, then for path 1, the present value is 70. Path 2, the present value is 74, and so on. Remember, we are just looking at one tranche, and we are trying different spreads. With those different spreads, each path will have a different value, and then assuming each path is equally likely, you have a certain average per path. Let us say that the observed market price plus accrued interest is 70.55. What is the most likely range for the option adjusted spread? So the correct answer is somewhere between 51 and 57. Why? Because based on these numbers, you can see that 70.55 is somewhere over here. So the option adjusted spread, which will give us a number in this range, would be somewhere between 51 and 57. There is a question in the curriculum which is like this, which essentially gives you a number here that is the same as one of these numbers, and then you are asked what is the option adjusted spread. It is just a complicated way of testing whether you understand this particular definition of the OAS. Calculating the OAS is impossible. That has to be done with a computer. So what the CFA Institute can test is whether you've understood the interpretation. So they'll create a big story, and then you just need to pick out a number. All right, so continuing with the interpretation of the OAS. OAS measures the average spread over the treasury spot curve, not the yield curve. So this is the precise definition. It's the spread over the spot curve. The OAS reflects credit risk, liquidity risk, and modeling risk. It does not reflect the option risk, which in our context is generally the prepayment risk. At level 1, we talked about credit risk and liquidity risk. So modeling risk is new. What is it? It is the risk due to assumptions made and input provided to the model. Now, where is this coming from? If you think about it, at level 1, we were dealing with relatively straightforward instruments. We had straight bonds, and then the most complex sort of instrument was a callable bond or a puttable bond. Now, our complexity has increased. Now we are looking at various sorts of tranches. We are looking at packed tranches. We are looking at support tranches, accrual tranches. So these instruments are a lot more complex, and when we use models to come up with the option adjusted spread, with any model, if you think about two possible issues. One issue is the assumptions that you feed into the model, and the other is the values or the inputs that you feed. For example, you feed a particular volatility assumption. How sure are you that that volatility assumption that you're feeding is right or not? So clearly there is uncertainty, there is risk. If you have a model that is very complicated, or a complicated model for a complicated instrument, would you as an investor demand some extra premium for that risk, the risk of dealing with complex instruments and complex models? The answer is yes. So that particular risk is appropriately called modeling risk. The more complex an instrument, the higher the modeling risk. And then the final bottom line statement that has been repeated often: OAS is a better measure than nominal spread because the nominal spread does not give us any sense for the prepayment risk. This connects with an earlier statement where we said that the OAS just masks the prepayment risk. Okay, now let's work through some examples. So these examples will help you with the category of questions where a particular analyst is saying something and you need to comment whether he is right or wrong, and if he is right, why is he right, wrong, why is he wrong. Assuming that mortgage-backed securities issued by US agencies have no credit risk, the OAS should be 0. So a given analyst says this. Is this true or false? This is false. Why? Even if we assume almost 0 credit risk, we still have the other risks. We have liquidity risk, we have modeling risk. So therefore, it is possible that different instruments will have different option adjusted spread. US agencies issue several different mortgage products such as pass-through, sequential pay, CMO tranches, PACs, and so on. Should all these products have the same OAS? Again, this is also false. Why? Because the level of complexity is different. The liquidity might be different. Do you think there is a link between liquidity and complexity? Generally, more complex instruments tend to be less liquid. So more complex, less liquid instruments will tend to have higher OAS, all else equal. All right, so point to remember: complex structures with more liquidity risk will have more liquidity risk and more modeling risk. The implied cost of a prepayment option embedded in a mortgage-backed security or asset-backed security is the difference between the Z-spread and the option-adjusted spread. This is fairly straightforward. We've said this several times. So if your Z-spread is 150 basis points and your option-adjusted spread is 110, what is the implied cost of that prepayment option? It is the difference between the two, which is 40 basis points. The option cost measures the option risk embedded in the security. We've again said this several times. It is not valued explicitly with some option pricing model. Now, what does this mean? You come up with the Z-spread based on the equal amount that needs to be added to the treasury spot rate curve. You come up with the option adjusted spread based on a model. In our context, for mortgage-backed securities and asset-backed securities, what's the best model to use? It's the Monte Carlo simulation model. So this 110 is arrived at using a model. But then for 40, do you use a separate option pricing model of some sorts, or do you just take the difference? You take the difference. So this 40 is implied based on the Z-spread and the OAS. The curriculum says that we generally don't use other models to come up with 40. Assuming similar interest rate risk and liquidity risk, so if these risks for two instruments are roughly similar, a high OAS would mean that a particular instrument is cheap or undervalued. Also, the term used is that it is more attractive. And this connects with the first reading in fixed income. So assuming similar interest rate risk, liquidity risk, and let me also put credit risk over here. So if these are similar for two securities A and B, then the security with the high option adjusted spread is relatively cheap We can also say it is undervalued. We can also say that it is more attractive. Okay, now let's say you are evaluating an agency CMO structure using Monte Carlo simulation based on a 12% volatility assumption. So try this before looking at the solution. So this is fairly straightforward. What is the option cost? It is simply the difference between the two. So if we put option cost for A, it is 30, for B, it is 35, and for C, it is 110. All right, so that's straightforward. It's simply the difference. Which tranche appears to be the most attractive? Now, we've said this over and over. When comparing, should you look at the highest Z spread, or should you look at the best option adjusted spread? Answer, as we've said several times, is you look at the option adjusted spread. But then you might ask the question, what about credit risk? The question says that you are evaluating an agency CMO, which means that the credit risk is low to negligible. So the question implies that the credit risk is comparable. So which one is most attractive? It is tranche A. Next question. Consider another CMO deal where you are deciding between tranche X and tranche Y. Both have an OAS of 100. All right. Now tranche Y has an effective duration of 6. Tranche X has an effective duration of 6. Tranche Y has an effective duration of 7. Which one appears more attractive? The point for you to remember, and the curriculum doesn't go into detail, so I just take this as a given, as generally OAS increases as effective duration increases. In other words, for higher effective duration, you would expect higher OAS. What is happening between X and Y? X has a lower effective duration, but both X and Y are giving the same OAS, which means that all else equal, X seems to be more attractive. Assumed interest rate volatility and MBS price. Here is another basic question. What is the relationship between assumed interest rate volatility and the price calculated using a Monte Carlo model? And the point here is that earlier I said that if this is your Monte Carlo model, one of the inputs is the volatility of interest rates. So you might tell the model that the volatility is 10%, or you might say that the volatility is 12%. And then what does this model do? It generates paths and then adds the OAS, and it essentially for every path it comes up with a present value or a theoretical value given that path. And then it takes the average. So that average is the ultimate price. What is the relationship between the volatility and this price that is ultimately calculated? So if the volatility is high, will the price of a typical mortgage-backed security be higher or lower? The answer is lower. Now, actually, let us also look at this question which connects with this point, and then we'll make sure that you understand the point. What is wrong with this picture over here? The issue here is that you are evaluating a particular security, and when your assumed volatility rate is 10%, the price is 100. If the volatility is higher, the price should actually be lower than 100. So this is the mistake. Now, what is the basic explanation for this? The explanation is the following. Imagine you are the investor, right? If you are the investor and let's say that the interest rate volatility goes up, what happens to the probability of higher prepayments? The probability of higher prepayments goes up. It is just like a call option. When volatility increases, the likelihood of the bond being called goes up. Similarly, if the volatility of interest rates goes up, then the probability of higher prepayments goes up. if there are more prepayments on a mortgage-backed security, assuming no credit risk, then the value of the security comes down. So the key point to remember is that all else equal, a higher assumed volatility will result in a lower price. If you found this video useful, please visit our website where you will find videos for all levels and all topics of the CFA exam.